Welcome everybody to a new screencast about MPS. In this one we're going to talk about intentions, which are basically quick fixes to improve your IDE. And on the other side of the Skype connection as usual is Vaclav. Hi Vaclav.
Hello Markus, this is Vaclav. Vaclav back on the other side of the wire.
Right. And so I guess we should start out with demoing what we want to do before we explain how we do it, right?
I think that's a good strategy. Yeah, let's do it. I'll demonstrate first what intentions are in case people don't know. Intentions, or sometimes called quick fixes, are the suggestions that IDE gives you and which are hidden behind this light bulb here. When I click that, you see there are a couple of things that you can do at the current place in the editor where you are. So this is like hints telling you, hey, the IDE can do this for you or that for you if you want.
Mm-hmm.
Now, clicking my mouse on this bulb just reminds me that I rarely use mouse to invoke these. Typically, I use Alt-Enter, which is the keyboard shortcut to invoke the same pop-up, and then just navigate through the brief menu to pick the one you want.
Right.
Like removing final modifier, press that, and the final modifier is gone. So that's pretty much the purpose of intentions, to help you. To improve your editor experience, the way you communicate with your with your IDE, with the code.
And this kind of intention that we've seen so far is kind of attached to one program element. In this case, it would be a local variable declaration, right?
Mm-hmm. Yeah, that's right.
There's also a different kind of intention which you can apply to a whole selection of stuff.
Oh, you're right. Let me select a piece of code. This one. Now. If I try, there's a keyboard shortcut called Control-Alt-T,
okay,
which pops up a menu with all so-called surround with intentions. So this is a special type of intentions that are aimed at wrapping a block of code with some other element.
Right.
So
I see.
you see in the menu you see stuff like for loop, for each loop, if statement. So you might say, and you might go and say, well, all this thing should be wrapped with an if statement. Since we are using projectional editor, this is probably quite important, more important than in text editors, I would say.
Yeah.
What do you think?
No, I agree. I mean, in a text editor, you can always type everything, right? In MPS, that is not necessarily true. It depends on how the language designer decided to make the language editable. For example, I suppose there is no way of just typing final in this thing, right? If you just try to type final, just try to type it.
Hey,
see, it did work. So it is possible.
It's possible to extend the language. I'm pretty sure there must be some action on the editor that does specifically this.
That is a so-called left transformation, which is triggered if you type something on the left of something else. But that people may decide, and you have to implement that manually. That's stuff you have to program to make that possible, right? It doesn't work with an if, for example.
Yeah, you can't start typing if. It's just being ignored.
Right.
If you want to do if, you have to either start on the line above and go if, and then copy paste the code inside.
Yeah.
Or you use this surround with thing where you say, oh, I really want to if. Notice you can type in here, right?
Yeah.
You can type and narrow down the list, which is quite handy.
So in other words, as you say, intentions are more essential to the editing experience than they are in text editors. In text editors, they may just be a convenience. Here, there may be cases where something cannot be done without an intention.
Exactly.
Right? So that's why when you work with MPS and you explore a new language, you should from time to time look at what the light bulb or the Alt-Enter menu tells you, so you can explore what the language allows you to do.
Right. Yeah, that's perfect explanation. Now, these intentions we've seen so far are intentions that come with the base language. So they've been prepared by the authors of base language. But you can add your own ones. And, you can add your own ones to either your language that you create or to the existing languages.
Well, technically you implement the intention in your own language extension, but it may apply to concepts defined in other languages.
Oh, thanks for correcting me. Yeah,
so
that's the way to put it.
Right. So the unless thing is one of these cases, right? Because the original base language doesn't know that there is another language which has an unless statement, which you then can use to wrap, around statements.
Exactly. So, base language authors have no clue that I will at some point think about creating unless. So I had to create intention for unless myself. So I had to, alongside with my language, which is wrapped here, I've got a bunch of intentions that I also distribute as part of my language, and the IDE will pick them as soon as I import that language into MPS.
Right.
So now these intentions are available, and surround with unless is the one we've been using here. So the one that allows you to wrap a selected block of code with unless block.
So let's step through it and see how it works.
Good, I'll do it. So at the first line we see that we're extending or we're adding this intention to the statement. Statement comes from base language. So this is an element we have no control over, but we want to create an intention that is somehow related to statement. So whenever a statement is selected, this intention is taken into account into consideration by MPS and offered to the user. And if the user decides to invoke that intention, now this is what happens. This piece of code here. So what we do here is we create a new unless statement. We retrieve from the editor all the selected nodes. And now what we do, we take the last of the nodes and we add next sibling. So basically, right after that node, we add our unless statement.
Okay.
And then we fill the unless statement with the selected nodes. So now all selected nodes, we move them from where they are inside into the statement, into the body of the unless statement.
Right.
So we go unless body statement add.
And when you say move, you just simply add them to the new statement list in the body of the unless statement. You don't have to remove them from their original statement list, because a node is always owned by one other node. And if you add it to another statement list, as we do here, it's automatically taken out of its original place.
Right. Okay, you're right. So you can never forget, that you can't have an element that would be in two places in the AST, right?
Yeah. Although, by the way, if you wanted to do that, I mean, technically, of course, it doesn't work, but you can always call .copy on any node, and it gives you an exact copy of the node, no matter how complex its internal structure. So, cloning model or program elements is easy to do in this case.
Good. Awesome. And notice we're not moving the actual elements, but their ancestors of statement. The closest ancestor which are statements, including the nodes themselves. This is the plus thing there.
So that's basically just to make sure that you don't happen to, forget to select the semicolon at the end, which would make the thing an expression.
Right.
And so it's just defensive coding.
A safety net, right? Sort of.
Yeah.
Yeah, and the last thing we do here, we select we command the editor to select the condition. So because that's the most likely place where the user will continue typing, so we just put the cursor right there.
Yeah, that's like positioning the cursor, setting the focus.
Right.
Right.
Good. So that's the surround with, and there's a bunch of other intentions that I created for unless, which might be worth mentioning.
Okay.
So once you are at unless, you might go and turn it into an if statement. So you say if not the original condition.
Right.
An intention has been created for. That's the turn to if statement intention here. Now notice, now it's pointing to unless statement, not to a statement. So it's only applicable to unless statements, obviously.
Yep.
And so now we get an unless statement as a node passed in the body of the execute method. And now we turn unless into if, and what we have to do, we just change unless with if, and we negate the condition. That's the high level idea.
Kind of the naive approach, always putting an exclamation mark in front of it.
Yeah, exactly, just as you say. So we go node condition. We take that condition and then try to transform it in a clever way into a new condition. So in some cases, we are able to create a new condition which is not just a negation of the original condition. Like, for example, if the original condition is already a not expression, then we don't have to negate negation. We just take out the original condition, the original expression, and make it the new condition. Or if it is not equals expression,
make it equals.
the condition, then we just go equals with equals. Or if it's greater than, then we go less than or equal, and so on and so forth.
Can I make a suggestion for improvement?
Oh yeah, sure, of course.
If it's false, make it true, and if it's true, make it false.
Oh, you know what? That's a clever thing.
I just thought about it when you did it in the sample code where it said if not false.
Yeah, right. That will make sense. Yeah. Although I don't think you typically find code like unless false in the real code.
True.
So I don't know whether people would appreciate, but for demonstration purposes, it would definitely make a lot of sense. Let's move on. What we do here. Right. If none of these apply, then we just create not expression and wrap the condition. So that's the naive approach. If nothing of the clever things, if none of them work, then we go directly and then negate condition. And now once we have the new condition, we can create an if statement node and set condition to the condition we created. Move the body from the unless statement into the if statement, and then in place just replace the unless statement with the if statement.
Right. So we've seen that before where we've used this add next sibling. It's actually quite convenient that the nodes present an API with which you can replace the node itself, or with which you can add something next to the node on which you call the API. So you don't have to find out, what's the containing statement, what's the containing role in which the node is located, and then put something into that collection, You can simply call these replace with and delete and add next sibling methods on the node relative to which you want to do something. That's actually quite convenient.
Right. Yeah, that's right. And also you don't have to bother with indentation and the visual aspect of how it will look like in the editor after your transformation.
Right, because that's defined by the editor, and it's just the model changes and it's just projected. As usual, it's always projected.
Yeah, so you change the model, and then MPS will take care of the projection, how it will look on the screen.
Yeah.
Okay. Well, the last intention I have is unwrap. So you might, if you want to get rid of the unless thing, now you decide I don't want unless anymore. Just get rid of it.
Right.
Now the unwrap intention is interesting in that it has also something in the is applicable part. So this time we don't offer this intention all the time, but only when a certain condition is met. And well, in our case, the condition is pretty straightforward, but can be involved if you need. Can be more involved.
Right.
So in our case, we just get the selected node and climb up the hierarchy until we find an ancestor that is an unless statement. And so this is because if you are in nested unless statements, you want to find the innermost unless statement. Innermost. That's the one you want to unwrap, not all of them at the same time. Right. So, MPS will always ask this intention whether it's applicable to the current node through the is applicable method. Well, and then to unwrap an unless statement now. So I'll go through this because I think there are quite some interesting ideas in this piece of code as well. So if you want to unwrap an unless statement, you get the parent of the unless statement, and if it's a statement list, you do things in one way. If it's not, you do it in the other way. So if the immediate parent of our unless statement is a statement list, so basically a list of statements, then it's easy. You just take all the elements from the body of the unless statement and put them inside the parent, the statement list, because it can happily take more statements.
Right.
So that's what we do here, right? So we just take the statement list and we copy all the elements from the unless statement into the parent. Right. Now, if it's not a statement list, though, then we wrap all the body of the unless statement. We take the body and wrap it inside block statement.
Okay. Block statement is basically an opening curly brace, closing curly brace.
Yeah, and that's what we replace the unless statement with.
Okay.
And that, so basically in place we just change unless with a block statement.
Right. Okay.
That's it. Okay.
Yeah,
well,
and then we delete the node.
Then we delete the node, right? So it's no longer there.
Okay. Cool. Well, I guess that's it, right?
That's all I have. Right. Do you think it explains intentions?
Well, I mean, in a screencast like that, you can never explain every detail and every API speciality and stuff, but I think it gives people a good overview of what you can do, what they're used for, and so I think we probably did achieve that.
Yeah. All right. Yeah, and if people are looking for inspiration, you can always go to the MPS, to the base language intentions, and take inspiration from how these are implemented.
Right. That is actually a very good trick that I always use when I work with MPS. I always look at example code, go to the definition of the thing, and then look for find usages. And so by this, I can, for example, find all instances of intention declaration, right? And then I just, double click my way through it and just look around. And usually, you do get some idea of how to solve problems.
Oh yeah, well, that's a clever trick.
Was told by your colleagues. Okay, then thanks guys for watching, and stay tuned for more screencasts. We're already thinking about creating new ones, and well, thanks Vaclav.
Thank you, Markus.
Ciao.
Goodbye.